Okay, this is a voiceover because the audio didn't record. We're looking at sections 551, 552, and this is really about transversals, which I'm explaining here. Basically, we have two parallel lines, as you can see all the diagrams on the right, have two parallel lines, and then one line that crosses it, and this line is called the transversal. So basically, the transversal is crossing the parallel lines and creates angles with those two lines. And there's certain relationships that occur between those two intersections. And then looking at this, we have a few details to get to. First, what we're going to look at is a linear pair. A linear pair up top. All right, I'm explaining something else here, obviously. So getting back into it, we are looking at a linear pair, and really that's just two angles that make 180 degrees. So you could think of opening a book. When you open up the book, you're creating an angle that is 180 degrees. It's a flat line, a linear pair creates a flat line, creates a line. So what we have is any two angles that create a line are called a linear pair. And that's just basically you add together those two angle measures, and that equals 180 degrees. This is also called the supplementary theorem. It's a little bit more of a formal term for it. But we have the linear pair. This is going to be important when we get to the relationships on the right side of the board. Next, we have adjacent angles. So adjacent, the word adjacent just means next to, and I think that with this, the key is that there's going to be a variety of angles if they intersect at one point, and the adjacent angles are just next to each other. So I think I'm going to get into an explanation here to help, bring that home. Basically, what I'm trying to describe is if you live in an apartment, your house has two neighbors or neighbors next to you. So if you have three apartments here, 1, 2, and 3. So if you live in apartment number 2, you share walls with apartment 3 and apartment 1. So if your next door neighbor is having a party, guess what you get to experience? You get to experience the party. All right, maybe you don't want to. But you have no choice because they're in the adjacent apartment. So the key is that if I'm in apartment 2, I'm adjacent to apartment 1 and apartment 3. This is a pretty basic idea. It just shows that adjacent angles share that one ray with each other. One of the angle sides segments is shared, and that's what adjacent angles are. All right, the third term we got to get through here is called vertical angles. And with vertical angles, the one thing we do know is that they're congruent. So vertical angles are just across from each other. So if you have two lines that intersect, just like a railroad sign, the top and bottom angles are going to be identical, and the left and right angles are going to be identical. So with this, you can think of this, one example would be like a pair of scissors. As you open the angle where your fingers hold on to the scissors, the blade side opens up to the same degree. So I think I'm going to get to doing an explanation a little further right here, but the basics is that the angles across from each other are congruent. So looking at the two yardsticks, as I open and close the yardsticks, watch what happens to the angles on the top and bottom and the sides. See, they're going to compress or stretch in the exact same manner as the angle that is across from them. So the angle on the top equals the angle on the bottom, the angle on the left equals the angle on the right. And as you move the sticks, those angles remain congruent. Their values change, but they just remain, they're congruent. So we always know that those vertical angles are always congruent, and that's helpful when we go to the definitions on the right side of the board. So just a moment for you to ingest that. Now, just like any of the relationships we're discovering here, there is a relationship between the two sides that are compared, or the two angles that are compared, and what we're going to do is relate any expressions that are associated with those angles or sides in the same way that those angles or sides relate. So since congruence is talking about, it just means the same, it's slightly different than it equals, just because we could transform a shape and move it, and it would be the same shape, but it would be in a different location. So looking at this, we have two vertical angles on the left and right of these two intersecting lines, and because vertical angles, so the argument is that since vertical angles are congruent, we can take those two values, the 2x plus 2 and 5x minus 4, and we can go ahead and make them equal to each other. Hey, I'm doing a voiceover, unfortunately. My audio didn't record, so I'm doing a voiceover on my video. It's hard for me to pause it, actually. Sorry. You can email me. All right. So I can take the two expressions, and I can make them equal to each other. So I just do so, and then this is just what we've been practicing all year. We have terms on the right and left, constants on the right and left, and what we're going to do is just move all the variables to the one side of the equation and numbers to the other, and then from there solve for x. So because I know the vertical angles, I know these two are congruent, so I can make them equal and solve for x. X is equal to 2. So we wouldn't be able to find x is equal to 2 if we didn't know that those vertical angles were congruent. Because they are congruent, we can equate them and solve for x. So just elaborating here that we use information about the angles, about the pair of angles, and from there we can assess the expressions that are included, that are involved. So next, this actually was an activity that we're setting up. This was a class activity to discover all those rules there that are now on the left side of the screen. And what we did is we took a piece of paper and a ruler, and we traced the edges of the ruler. So essentially, my question is, why did we use a ruler? What kind of lines are created when we trace both sides of a ruler? And looking at that, if I have two lines that are equal distance from each other, because the ruler is the same width all the way across, if they're equal distance, then they are also parallel. So we created parallel lines, two parallel lines, just by making tracing the edges onto a paper. So my example on the very far right of the screen is the first step. We create the two parallel lines, and I go back. And what kind of line am I adding now? What is that line called that crosses the parallel lines? That is the transversal. So basically, when I was writing this also, we want to avoid those lines being 90 degrees, because then it's harder to see the angle relationship, since they'd all be 90 degrees. So what I'm going to ask the students to do, and it might be paused, but I'm not sure, is to go ahead and cut along the line. So you're cutting your paper into 6 different pieces. So I cut along the lines, cut along both parallel lines all the way across. I cut along the transversal all the way across. And from there, we're going to end up with 6 different pieces, and they're going to match kind of what I have there on the board. They're going to match where you can take each angle and move it around and see what else, where else it fits. And really, that would be a test for congruence. Okay? Also, we're going through, and this is actually before they cut the paper, you want to go ahead and label the angles in the same exact way that I did. So it's a little hard to see, but the top intersection, it starts at 1 at about 9 o'clock, and then it goes to 2 up and to the right, then it goes down to 3 and over to the right for 4, and it follows the same pattern for the others. So just so that the angles match when I'm doing the explanation, you really need to get those angles identified correctly. So while we're waiting, maybe if you're not doing this activity, I'll just kind of fill this time a little bit. So looking at the 2 parallel lines in the transversal there that I have on the board, you could see that, if I get out of the way, you could see, move. You could see that in between the parallel lines is our interior angles, and on the outside of our parallel lines is the exterior. So what I'm doing now is at the top intersection there, I've isolated angle number 2. And in the bottom intersection, what angle corresponds to the same position as angle 2, but in the lower intersection? So let's see. We know that it's up and to the right. So what I'm going to do in the other intersection is take away all of them except for that angle number 6. So if I pick up 2 and I move it down to where angle 6 is, look, it fits perfectly. So what I know about those 2 angles are that they're congruent. So I can go ahead and put the 2 back, and over in our notes, under corresponding angle, the first top one on the top right there, I know that corresponding angles are congruent because I just picked it up and saw that it matched. Okay, so if we were doing a problem with these corresponding angles, I would go ahead and equate any values or expressions that are associated with those angles. I would equate them to each other because they're congruent. And here's another example of corresponding angles. So angle 1 and angle 5 correspond. And I'll show just another one probably. Yep. All right, so that's angle 3 and angle 7. They're corresponding angles. It's not exclusive. You can have 4 different corresponding angles, and you always do. You have 4 angles that correspond to each other. So the rule I wrote there is that corresponding angles are congruent. And you can see I put the tick marks on those angles, the angle 1 and angle, I guess that'd be 6. Angle 1 and angle 6 are congruent, just as, angle 2 and angle 6 are congruent, just as angle 1 and angle 5. Basically, complementary angles, corresponding angles are always just in the same position as in the other intersection. You might also note that those parallel lines are labeled L and M, and notice that we put the label of lines, we write it in cursive. So those 2 parallel lines are L and M, and then the transversal is in. So now what I'm describing is alternate interior angles. That's on the left side of the board there. Alternate meaning that they're on alternate sides of the transversal, but they're interior. They're on the inside of the parallel line. So you see I moved away all those exterior angles, and now I'm just pointing out that that angle I picked up and moved to the other one, alternate interior angles are congruent. It fit perfectly in that other angle. So alternate interior angles, we're talking about alternate sides of the transversal and on the interior of the parallel lines. So now, just to double check here, I could pick up one of them and see if it fit into the other space. I guess I'm just showing that these are the other pair of alternate interior angles. So we all have 2 pairs, and now just put it all together. I guess I'm going to go down to alternate exterior angles, AEA. So those acronyms are also what we'll use and identify them with. So alternate exterior angles, we could just call it AEA. And so alternate, again, talking about on alternate sides of the transversal. Exterior is talking about on the exterior side of the parallel lines. So I think for this, I'm going to probably move those interior angles out of the way. Let's see. Looks like someone's asking a question. All right, so yes, I'm looking for those alternate exterior angles. So the angles I moved out of the way were on the interior, so I'm just looking on the exteriors. and it's on alternate sides of the transversal. So that is comparing their angle 1 and angle 8. So we pick up angle 8 and move it over. It fits perfectly in angle 1. Hey, I'm actually recording stuff. Sorry, man. Yeah, see you. So we have these alternate exterior angles, and they are congruent. We just picked it up and moved it to the other space, so we know they're congruent. So with this, I can write that AEA are congruent. All right. So we had complementary angles, alternate interior angles, alternate exterior angles. These are all the three relationships between transversals and parallel lines that are congruent. This shows which angles are the exact same. Okay? So now I'm going to piece this back together and go through the last two identities. So now we have consecutive interior angles. So first off, I know they're interior. So where am I going to focus? I'm going to focus on the interior of the parallel lines. And then they're consecutive interior. So what's on the inside, and part of these definitions are always in relation to the transversal. So since they're consecutive, okay, just moving away the exteriors, so now interiors, the ones that are consecutive are on the same side of the transversal, and they are in the consecutive position. So we have either of those options are consecutive interior angles. And now just to see how these consecutive interior angles fit together, pretty sure I'm going to go ahead and, not sure what I'm doing, obviously confused. Oh yeah, so I was explaining that if you were going along one of the parallel lines and you turned at the transversal and then turned again to the other parallel line, you'd essentially be making a U-turn, right? You'd make a U-turn, and if you make a U-turn, you'd turn 180 degrees. So I was spinning because a full spin is 360, but if we have consecutive interior angles, you're only really making a U-turn as far as your angles and how you move through that. So with consecutive interior angles, we know that they're supplementary because they add up to 180. You're basically making a U-turn. So now we're looking at the last one, same side exterior. I moved out the interior angles. It's on the same side of the transversal, on the exterior of the parallel lines, and I move it, and what does it make? It makes a straight line. So I know that these two angles are definitely a linear pair. So because it's a linear pair, we know that they add up to 180 and they are supplementary. So these are the five relationships that basically break down how parallel lines and transversals interact. These are going to be key. And again, if you are relating to sides that are congruent, you can make them equal to each other and solve for x.